Good morning to all. In this video we study the LDR characteristic. So for that, this is a list of components that is required for this setup. So the LDR chosen as number GL12528 12 volt bulb, then fixed resistor, and these are the minimum required components for this setup. And you can also go through this schematic. So 230 AC, this is a transformer, step down transformer, 012, bridge rectifier, filter capacitor, power indicator, LED, resistance in series with that. This is 5 volt regulator 7805, and this current limiting resistor 3.3 kilo, and this is LDR, that is GL12528, and there is a emitter in series with LDR to measure the current through this LDR, and there is a bulb which connected in series with this dimmer circuit and the current meter. So the dimmer is a simple power, or we can say that PWM dimmer, and the setup is looking very simple. This is LDR etc. So in the characteristic there is two cases we can discuss here. So case one is that we kept the distance in between the source and the LDR is fixed. We vary the power of the bulb, that is light intensity. So for sake of simplicity we take as 10 centimeter in between them. We vary the power from low to high and record the current through this LDR. So this is case 1. In case 2 we make sure the power feed to the bulb is fixed and we vary the distance between the bulb and LDR. So we kept power constant of bulb, change the distance, record the current to LDR. So from these two cases we get these tables. For the first case, distance is fixed, that is 10 centimeter, and we vary the power feed to this bulb, and we get proportionally current through this LDR. So for the case 2, we kept the power feed to the bulb is fixed, that is 0.25 into 12, and we increase the distance of the LDR, and in between the LDR and the bulb, when we increase the distance, the current through the LDR is decreases. Inversely we can say that in the case 2. We just plot these two cases where the distance is fixed and we just increase the power of the bulb, and we get the proportionally relation of the current through LDR. So in case 2 we make the power fixed and we just increase the distance, get the inverse of we can say that when the distance is large there is a less current flowing through the LDR. Okay, so in further video in the further continuation of this experiment, my colleague do the experiment on this on the actual board, so you know more about this. This is basic simple setup for the LDR characteristic. You can alter the points like that. When you want some different LDR, you can go through these data sheets, what is its light resistance and the dark resistance. According to that you can select the series resistance and the also what kind of the bulb you are trying to use, AC, DC. Accordingly you can change this setup. For my setup it is most likely suitable, so I kept these values as it. So I hope you found this simple circuit useful. and you can continue with the further video. Thank you for this.
This is our demonstration for LDR experiment. This we are connecting the transformer, step down transformer, which gives the 12 volt supply. Here is the bridge, rectifier, and the LED indicator is there. After that we have connected the filter to get the 12 volt DC supply, and this is a regulator to get the 5 volt power supply of LDR. This 12 volt dimmer. Then here is our setup for light source as a bulb, which is 12 volt bulb, and this is the LDR. Here we are connected to multimeters, which we are using as a ammeter. This ammeter measure set at the 10 ampere, which measures the current through bulb, and this multimeter is set up at 2000 microammeter, which measures current through LDR. This is our setup to vary the distance. This way we can vary the distance between light source and LDR. This is kept in an enclosed box so that external light will not affect the LDR. So there are two cases in our LDR experiment. In case 1, we kept the distance constant and we are varying the power of bulb. With the help of this dimmer, we are varying the power of the bulb. As we can see here, the circuit is open. Initially it is at off state, dimmer is at off state. When we vary this, you can see there is a change in the intensity of the bulb. With the change in intensity of the bulb, the resistance of the LDR varies, and you can see there is a variation in the current flowing through the LDR. So initially when dimmer is at 0, current is also 0. When we increase the power of bulb, here you can see the variation in the current is increasing, and here it shows the current through the bulb, which is also increasing. So the case 2 of the experiment is that we are maintaining the power supply, power of the bulb constant, and we are varying the distance of the LDR. So initially we kept the current here at 0.30 or 31. You can see here the dimmer position, and with the respect to this we get the current through LDR, that is 155 nearly. And here you can see the distance we kept, nearly 30 centimeter. Okay, now we vary the distance to 15 centimeter. Now you can see the change in current through LDR, which is 320. So as the distance decreases, you can see the current is increasing.
This is our bulb light source, and this is our LDR setup. Okay, so to vary the distance, we are using this kind of arrangement here, like this, to vary the distance between the source and the sensor. Okay. This wire is coming out from this cardboard for the connection to the main circuit LDR, and this is for the bulb. Okay.